Look at PLDs, programmable logic devices, and there are three types in it. The first one is ROM. This one is called read-only memory, and then we have PLA, that is called programmable logic array, and then also we have PAL. This is programmable PAL. That's programmable array logic. And PLDs are aligned. PLDs are built here based on AND gates and OR gate. So it will be always aligned like this. And all of these types have different thing in it, like ROM. For ROM, AND gate is fixed, and the OR gate is programmable. And for the PLA, both of them are programmable. AND gate also programmable, and also OR gate also programmable. And for the PAL, AND gate is programmable, OR gate is fixed. Okay, this is the difference. Now here we are going to look at ROM. Okay, ROM, we have seen here the AND gate is fixed, OR gate is programmable. For the AND gate, we can use decoder because at the end of the decoder, there's an AND gate. For the OR gate, we just use OR gate. So for the AND gate, we use the decoder, and OR gate remains the same. And AND gate is fixed, OR gate is programmable. That's all we have to know. Now let's look at a problem using that. So here is a question. Design a combinational circuit using ROM. The circuit accepts a 3-bit number and outputs a binary number equals to the square of the input number. Okay, so they have mentioned this is a 3-bit number. It means 3 inputs. Like 3 inputs mean, let's say A, B, C. So we are going, if it's 3 to the power 3, there are 8 different orientations. We are going to have 0, 1, 0, 1, 0, 1, 0, 1, and then we are going to have 0, 0, 1, 1. It's better to divide so you can see the the line related connected with it. Okay, so 0, 0, 1, 1, 0, 0, 1, 1, and then here 0, 0, 0, 0, 1, 1, 1, 1, and here we have 3 inputs. Okay, so for this one, we have to decide how many output we are going to use. For that, you have to look at, like here we have 0 and then 1, 2, 3, 0, 8 different orientation. It goes up to 7, and here they have mentioned outputs the binary number equal to the square of the input number. So it outputs the square. So if it's 0, it's going to output 0. If it's 1, it's going to output 1. If it's 2, it's going to square the, like 0 square is 0. That's why it's 0 output. 1 square is 1, that's why 1 output. And then 2 square is 4. So you have to look at, okay, this is 0. If I write in number, this is 0, 1, 2, 3, 4, 5, 6, 7. So I just wrote this one in binary, I mean decimal. So these are the decimal equivalent. If you look at in decimal, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, and 7 square is 49. 7 is the last number, and 7 square is going to be the biggest number. So biggest number is 49. Now we have to see which power, because to decide how many outputs we are going to have, we have to decide how many of power we need. Like for example, if I take 2 power 5, that is 32. So if I take 2 power 5, it means all the powers before also come with a, like, it start from 2 power 0, then 2 power 1, 2 power 2, 2 power 3. That's the, like, if you remember converting binary to decimal, you will remember like binary numbers start like this. It start from 0 and then doubles each time. 0, 1, 2, 4. These are like 2 power 0. 2 power actually start from 1. 2 power 0 is 1, and then 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8, 2 power 4 is 16, and 2 power 5 is 32. And 2 power 6 is 64. Now to make this 49, we don't really need the 64, because if we take a 64, that is already above 49. So we don't need this. We only need up to this 32 and a 16 and a 1, that gives 49. So this is 32 plus 16, 48, 40 plus 1, 49. So this is enough. So how many output do we need? We need 6 outputs. So we can name this one as we want. You can start from B0 or B1, but we have to make sure we have 6 at the output, because then only we can make it to 49. Okay, so I'm just gonna erase this. Okay, let's start from B1, B1, B2, B3, B4, B5, B5, and then B6. That's enough. We need to just have 6 outputs, 6 bits output. Okay, so here for the 0, 0 square is 0, so all of them just 0. Okay, to remember is best, like if you want to just remember it better, you can just put it like 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, power 5. And if you want to write it in decimal, this is 32, 16, or just remember as power. Like, I don't want to put so much detail and mess everything. Just remember these locations represents these things. Okay, so first one is 0, the second one is 1 square is 1, so I put 0 for everything, and the last one is 1. So the 1 at 2 power 0, that's equal to 2 power 0 is 1. And then the next one is 2, but here they say output is square of that, so 2 square is 4. So we have a 1 at 2 power 2, and others are 0. And the third one is 3 square. 3 square is 9. So we need an 8, that is 2 power 3, and a 1, that is 2 power 6. Others are 0. And then 4 square, that is 16. 16 is already a 2 power 4 is 16. So there's a 1, and others are 0. And then 5 square is 25. Here we have a 16 plus 16 plus 8 is 24, and a 1, 25. Others are 0. And last, no, we have one more. 6 square, that's 36. So here we have 2 power 5, that's 32, and a 4 will give us 60. 36. Others are 0. Okay. And the last one is 7 square, that's 49. So for the 49, for the 49, we can take a 32 and a 16, 48, and a 1. Okay, that's it. Now we have to see whether we can simplify this one, because we want to build the circuit as simple as possible. So to look at that, first as I see, this whole thing is 0. So you can connect the B2 to the ground, because this is not necessary. We don't need that. And if you look at B1 and C, you compare B1 and C, both of them exactly the same. 0, 1, 0, 1, 0, 1. So we can connect the B1 to the C. And others, I don't see anything matches this pattern. So we keep it as it is and design the circuit. I'm going to use the next page to design the circuit. Okay, first we are going to use a 3x8 decoder. So we have 8 output. I'm going to use a 3x8 decoder. We have 3 inputs. Three inputs, A, B, and C. And we have 8 outputs, that is 0, 1, 2, 3, 4, 5, 6, 7, 8. And this one is 3x8 decoder. I put a line for each of them. Okay. Now from this one, we see that B2 connected to the ground. B2 is 0, so it's connected to the ground. Or you can just connect a 0 for it. Like connect a 0, connect that one to the B2. And B1 is exactly the same output as C. So we connect that one to the C right here. Okay. And we have taken care of B1 and B2. The left are B3, B4, B5, B6. For that one, I draw a line here. 1, 2, 3, and 4. At the end, we connect an OR gate. And the output is B6 here. This one B5. B4. B3. Okay, that is it. Okay, now let's look at the output. So You look at here, B3 is turned on when it's 2 and 5. Okay, 2 and 5. 2. The B3 is turned on at 2 and 6 actually. Let me double check. B4 is turned on at 3 and 5. Yeah. B3 is turned on at 2 and 6. Let's put that one right here. 2 and 6. Use a different color so you can see. It's connected at 2 and 6. You have to just look at where are the ones and connect them there. Okay. And I realized that put one extra here. If you are starting from 0, it's only up to 7. So 0 to 7 is 8 output already. Okay. So that's for B3. And if you look at B4, B4 is 1 at point 3 and 5. So I put the cross marks at 3 and the 5. Okay, and then B5 is on at 4 and 5. So I put 4 and 5. And B6 is turned on at 6 and 7. 6 and 7. Okay. So that's basically it. So let's check an output of let's say for example I'm taking 101. 101 B1 is B1 is this one right here. So that's the last part is C. So that will be 1 and B2 is always 0. And 5. If I look at 5, 5 is 101 is 5. Right? So if I look at 5, 5 is on at B5. That is 1 right here. And also on at B4, I put a 1 right here. And then I put zeros for the other thing that's not connected. And if you look at this 0 1 0 0 1, here this is, if you look at put number, like if you represent the weight of the binary numbers, binary number weight start from 1 2 4 8 16 32. Okay, this one is 16. 16 plus 8 24. 24 plus 1 is 25. It's 16 because you see, if you look at from this order, this is 1 and then second one is 0 and then 4 is 0, 8 is 1, so I mean 8 exists, 16 also exists, 16 and 8 exists, and also 1 exists. So 16 plus 8 24, 24 plus 1 25. That is for 101. That is exactly the same output we have right here. Like that, if you grab any number, you can verify with this one. Like for example, if you grab 110, this last digit represents B1 because C is, this is A, B, C, right? So C is 0. Whatever the C value holds, that's going to be the B1 right here. So this is going to be 0 right here. And this is always 0. And then this one number, like this is 4 plus 2, this is 6 in decimal. So you have to look at 6 and look where it's connected. 6 is connected at B6. So erase and rewrite. 6 is connected in B6 and also at B3. And others are 0. So if I verify this one, 32, the third one is 4. 32 plus 4, 36. 6 square is 36. So like that, you can verify all the numbers to make sure that logic design that you design is correct. And that's it for this video. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.